Alright, so let's talk about the effects of test redundancy on software. So what do I mean by test redundancy? There are two flavors that you need to be aware of in your test suites. One flavor is partial redundancy or partially redundant tests. Partially redundant tests are test cases that cover each other, although not completely. So for example, we have two test cases, A and B, and if test A does some of the things that test B does, they cover each other and they are partially redundant. Okay, the coverage does not have to be complete or continuous like in this simple cartoon right here. The coverage can actually be discrete and jump around, but as long as one test covers the other in a partial manner, they are called partially redundant. Now, test coverage is not to be confused with code coverage. Okay, those are different things, and I will talk about that later. The other flavor is total redundancy. Total redundancy happens when two tests either do exactly the same thing or when they test the same thing, although in possibly different ways. Okay. Now, just to make it clear, it does not make two tests are not redundant when totally redundant when if they have the same goal. Okay, so say for example I have two tests, and one is testing that I can retrieve charts via the command line, and the other test is testing that I can retrieve the same charts but via the GUI. Those tests are not redundant because they don't have the same intent. Even though they have the same goal, which is the charts, they don't have the same intent. So let me give you an example of a totally redundant test. So for example, here we see two tests, test 4, test 5, T4, T5. And this is in the Java language. So you can see, for example, that the number of pushes on the stack is the same in both. Okay, so they both go about doing the same thing. They test the same thing. Their intent is the same, but they go about it in different ways. Okay, and these types of redundant tests are very hard to catch. Okay, redundant tests, totally redundant tests, are also called duplicate tests. Okay, so why should you care? Do duplicate tests matter? Do in particular do duplicate tests affect and in any way the bug detection ability of your test suite? Well, it turns out that they do. In a study done by Ortask with more than 50 test suites spanning 10 popular open source projects, it was found that the higher the test duplication in test suites, the higher the relationship with bugs. Okay, so in other words, there's a link between the amount of test duplication and the amount of bugs. The higher the duplication of tests, the higher the bugs. Okay, now let me explain this chart right here. This is the linear regression of the data, and this gray area right here is the 99% confidence interval. This means that the linear regression is 99% confident that the projects will fall within the gray area. Now, although the regression is not perfect, it is telling and it is on par with code coverage. So let me show you that. This is the chart for code coverage, and you can see that the regression is also not perfect, but as we expect, the higher the coverage, the higher the code coverage, the lower the bugs will be. Okay, so there is an inverse link, and the way to visualize this is like this. So on the left-hand side, we have the correlation of test duplicates versus likelihood of bugs, and it's a positive correlation, meaning that the higher the number of duplicates in your test suite, the higher the likelihood of bugs. Okay, contrast that with the correlation between code coverage and the likelihood of bugs is a negative correlation, meaning that the higher the code coverage, the lower the likelihood of bugs. Now, one thing I do want to point out here is that they are both almost the same strength, although one is inverse, but they are almost the same strength. Okay, so actually, it means that test duplicates do have a strong correlation between or with likelihood of bugs in projects. So what this all means is that the benefit that you achieve with high coverage in your test suites is undone by the test duplication that you leave in your test suites. Okay, So moving on, let's look at the this chart shows the code coverage against the regression detection. Okay, this is another important aspect of test suites to detect regressions whenever um, your system under test changes, whenever your system under test evolves. And you can see that the higher the coverage, the higher the regression detection capability of your test. Okay, and this is expected. However, this is very interesting and very telling that the higher the test duplicates, okay, the higher the amount of duplicates in your test suite, the lower the regression detection capability it has. Okay, so again, visualizing these correlations, on the left hand side we have the inverse correlation between test duplicates and regression detection, and on the right hand side we have the positive code coverage versus regression detection correlation. So on the left hand side, again, this means that the higher the duplicates in your test suite, or in other words, the higher the amount of duplication or test duplicates you have in your test suite, the lower your test suite is capable, or the less likely your test suite is capable of detecting regressions. Okay, and this is very, very important. So this is the direct relationship between code coverage and test duplication. And you can see here that as the code coverage, as test duplication increases, code coverage actually goes down. And this makes sense, right? Because in the extreme case, it's always a good exercise to go to extreme cases like in mathematical terms, in the limits. In the limit, we can think of one test suite composed of 1,000, 1,000,000 tests, but they are all doing the same thing, you know. And this means that the higher but that's just one extreme. Of course, it doesn't happen in real life, but it does occur that, as this relationship shows, that the higher the amount of duplicates in the test suite, the lower the coverage is going to be. Okay. So what can you do about this? What is this? What can you do to alleviate these issues? Well, there are several approaches, and the approach that I prefer, and that I'm sure you prefer as well, because it's just simpler, is the automated solution. Okay, so one thing you can try is the ORTAS test list, and ORTAS test list is based on the ORTAS comparison engine, which was used in the study. Okay, the other thing you can try is doing homegrown solutions. There are a lot of great academic research papers out there that go ahead and make their own test comparison systems. However, they are not scalable. They are based, the majority are based on machine learning algorithms, and they take a long time to learn, to tune, and they are not scalable. They do well with little sample tests, little lab test suites, but they don't scale to real life test suites like in open source projects, for example. The third approach is a manual solution. Okay, for this, I strongly recommend to first establish a common terminology. Okay, by what do you mean by test duplication, test coverage, and partial redundancy? For that, I recommend that you go to the white paper section of ORTASK and read up on research that we've been doing for that, exactly that. There's a lot of good terminology in academia that is unfortunately lacking in the software testing industry. So what I mean by that is that it's common, and I'm sure you're going to agree with this, it's common to stumble upon colleagues and teammates that have very different notions of what it means for a test to be a duplicate of another test, or what it means for two tests to be redundant. Okay, everyone has a different definition, unfortunately, in industry, whereas in academia and in particular in the white papers, it's a very specific, concrete, explicit mathematical definition that scales well to real life projects, in particular real life test suites. So once you've established a common terminology, I recommend that you look at and use code coverage tools. Okay, so in particular, you want to look at for lines that hit multiple times. Okay, so what I mean by this is, take for example this snapshot of a Ruby code coverage tool called SimpleCov. In this particular class, it's 97.06% covered, but the average hits per line is excessively high, meaning that it's extremely likely that the test suite that is testing this class has a high amount of duplication, and you can start from there. Okay, and this is because of the correlation between code coverage and test redundancy. And after you do that, I recommend that you manually and frequently inspect your test suites and do away with duplicates. That's the only way you can keep your redundancy low and your bug detection capability and your regression detection capability high. And yes, it will take time, and yes, it is error prone doing manual. That's why I recommend going the automated solutions, going the automated route. Okay, and I hope you have enjoyed this little brief test bite on the effects of test redundancy on software.